Good morning to all of you. Good morning, students. So, we are back again with our physics class, and also came back to stop many of you from your personal chats that is going on. So, we are going to continue with differentiation. Good morning once again. Good morning to all of you. So, we are going to continue with differentiation. We saw in the last class what is the meaning of differentiation, what is dy by dx, and we saw some important formula, one of the most important, which is x to the power n, derivative or differentiation being nx to the power n minus 1. And based on that, few examples, then also how it is derived using ab initio method or first principle method, and then I said that rate of change or derivative of sine, cos, tan, cosec, and cot, then e to the power x, natural log x, these all derivatives we have seen. And towards the end we were discussing a few rules of differentiation, and as far I remember, then we had seen rules like if a constant is directly given, that means you have its derivative to be 0. If a constant is multiplied to a function, then you keep the constant as it is and you just differentiate the function, right? This thing we had seen towards the end. Okay, so let's continue and come to the other rules of differentiation, and then as usual, as we have been doing, whatever mathematical concepts we are reading or we are coming to know, those we are applying to physics also. Ultimately our goal is to use these tools in solving physics problem, so we should definitely have some examples of physics where we can use these tools. So we'll be doing all that stuff today. Okay, so let's start, and please keep a check to whatever chats you are into or what comments you are writing or sharing or exchanging with your friends. If it is anything out of the context or whatever is not pertaining to class, you will be simply removed from the classroom, so please be aware of that. So here, coming to next rule, whenever you have a function which is not a single function but a sum of multiple functions or difference of multiple functions, you keep on adding several functions, then addition or subtraction rule of differentiation, if you are asked to write dy by dx, what you will simply do is differentiate each function as it is, and whatever is the plus or minus given in between, just keep that unchanged and just keep on differentiating each function. For example, if we take y is equals to 2 sin x minus 4 x to the power 1 by 2 plus 1 by 3 ln x, just as an example, plus 5. So we have been given this. Very easily we can do what? If dy by dx is asked, we will individually differentiate each one. 2 we know is a constant, keeps like that only. Sin x, I think the rebels, in English we call rebels, in Hindi there is a term called baghi, means those who openly challenge the system, they won't listen to what is being told to them. So I think we have the first Ayano Koji and all, I don't know what all names you keep, so you are being removed. 2 sin x becomes 2 cos x minus sin, as it is you have 4 is a constant as it is. So we will differentiate x to the power 1 by 2. We have seen x to the power 1 by 2 differentiation will be 1 by 2 x to the power 1 by 2 minus 1. Then we have 1 by 3 as a constant. Log x differentiation we know is 1 by x. Then we have a constant 5, constant differentiation is 0. So directly we have 2 cos x minus 4 by 2 will become 2, x to the power minus half goes down, so by x to the power half, which is root x, plus 3 by x. This will be our answer. Clear? Yes. Then next we have so we can write dy by dx 2 x square will become 2x, 4 x with respect to x will become 1, minus 5 cot x we have seen is minus cos x square x. So from here we can write it as 4x minus 4 plus 5 cos x square x. So if you would have seen the last class, all the important derivatives I have already told, you all would have noted it or taken screenshot. If anyone has any confusion that Arey sir how you wrote this thing, you can cross check with that page where you have written the important formulas. So I am using only those terms which we have already discussed in the last class. So this is a simple application where we have sum or difference of several functions, and if you know the derivatives, you just need to individually differentiate, and whatever the sign comes in between plus or minus, keep that as it is, and then you get your answer. Okay, if you wish you can take a screenshot now, or you very well know that later in your free time you can watch the video and make a complete note of whatever is written on the board. Okay, so now let's move on to the next application or next rule. I am sorry, not application, next rule, which is multiplication rule. So multiplication rule, whenever we have y is a function of x and we have say two functions which are being multiplied to each other. Suppose we have two functions which are multiplied to each other, f1x and f2x. It can be any functions. I am writing the names f1, f2 just to name the functions. They can be any, they are being multiplied. So in that case, what you have to do, just remember that each one is to be given equal treatment. That means what you will do, first function you will keep constant. First function you will keep constant and simply differentiate the second function. And once you have done this, exact treatment you have to do for the second one. So first function constant, differentiation of second one, plus, give a plus sign in multiplication. Now take the second function constant and simply differentiate the first one. So this is the rule that we use in multiplication of two or more functions. Not only 2, 3, 4, 5, as many it can be, you can use the same. If there are multiple functions, you can simply keep one of the functions constant, other one, who is Babu Reddy, listen what I am saying. Once again, this is not a singing or dance show going on once again. I have told you what you could not understand, we always have that option of later on seeing. But see, I am telling, I am repeating myself. Don't write once again. I am telling it. Listen instead of commenting. When I'll ask you for your responses, respond then. Two functions given, first one constant, second one differentiate, plus second one constant, first one differentiate. Okay, so by example it will be clear, and if you have not seen the last class, better you see that, then you will be able to understand. So here, example. Suppose we have an example where we have y equals to x square log x. Y equals to x square log x. So if I am asked dy by dx, now you can see there are two functions. One is x square and one is log x. So what you have to do, first you will take x square constant as it is, and you will differentiate the second one, which is log x. Then what you have to do, put a plus sign. Then put the second function constant, log x constant, and differentiate the first function, that is x square. Understood? Now, rest is about formula x square. Differentiation of log x with respect to x is 1 by x. Then here we have log x and multiplied by x square, differentiation is how much? 2x. Now you can see one x cancels. So we have x plus 2x log x, which you can take common also and write. If you take x common, you will have 1 plus 2 log x. This is our final answer. So yes, x plus 2x log x, which you can take common x as, and you can write 1 plus 2 log x. I hope this is clear. Another we are taking y is equals to x cos x. If we have x cos x, dy by dx just by the same rule, x constant, differentiation of cos x minus sin x, plus cos x constant, differentiation of x, which is 1. So here we have 1 into cos x is cos x minus x sin x. So dy by dx becomes this. Is it clear? So now let's move on to our next rule, which is called as the division rule. So just like we have multiplication rule, we have division rule. Okay, we are being asked by Reddy Palli Kavita. Okay, sir, say with 3 or more terms in single question. Beta, if you have 3 or more terms in single question, you can use the same rule. See how? As many they can give you. As many they can give you. If you have y, u, v, w and so on, multiple terms. If they give you multiple terms, so what is to be done in such case? You will have to keep 2 constant, differentiate third one. So keep on doing, that's it. So if they ask you dy by dx, so example, if you have u, v, w, 3 terms, so what you will do here, you will keep u constant, just I am showing why it will come, u constant and differentiate vw, plus vw constant du by dx. You can do like this. Now you can expand it just to show what you are finally going to get. For 3, 4, as many terms it can be. This you can individually write, and I will then finally write a generalized solution which you can remember. We can write vw by dx plus w dv by dx. This is done. Plus vw du by dx. So if you see now what you are finally getting, uv dw by dx plus uw dv by dx plus vw du by dx. So basically what you have to do, you have to simply take two constants, differentiate the third one, that's it. You can generalize in this particular way. Understood? So in this particular way we can proceed. So here example, if they give us two x square tan x natural log x. Array, you take any one first, all are, there is in multiplication rule, there is no priority because all terms you can see are coming same. Any two constants, third one differentiation. Look over here, Junior Itachi, why I don't know what sort of names you keep, I cannot spell all that, I am very sorry, but simply you take any two constant, differentiate the third one, this is the only concept, plus uv, uw, vw, whichever term you write first. In addition, you know 2 plus 3 is equals to 3 plus 2. So there is not going to be any change. 2x square tan x log x. Directly I will write dy by dx. How? Take 2x square tan x constant. Natural log x differentiation 1 by x. Then take 2x square and natural log x constant, then differentiate tan x will become x square x, then take tan x and natural log x constant, differentiate 2x square will become 4x, that's it. So from here x cancels, so you can see 2x tan x plus 2x square natural log x square x plus 4 tan x natural log x. That's it. There is no need of complicating things unnecessarily. Simply you will have terms like this. Take two constants, differentiate the third one. Is it clear? Similarly, if you have 4 terms, take 3 constants, differentiate the fourth one and keep on taking all the possibilities. That's it. Is it clear to everyone? I told 2 times. Now again that once more should not come. Okay. Sir, once more. It's not an Indian Idol show and you know that I am rude. Both things should be kept in mind. So this is done. Now once we know what is multiplication rule, we will now move on to what we call as division rule. Now even though division rule can be also solved by what we call as multiplication rule, because you know division is nothing but multiplication in reciprocal. For example, if I say u by v is nothing but the multiplication of u into 1 by v, and if you know the differentiation of u, if you know the differentiation of 1 by v, then you can easily find the differentiation of u by v. So just made it clear to you that division is nothing but multiplication in reciprocal. So when we have this thing over here, then we have this thing over here, y is equals to, suppose f1x by f2x, if this form is given. So this is our numerator. Let's call the numerator as nr, and this is the denominator as dr. So when you have to differentiate y, that is dy by dx, what you have to do, first keep denominator constant, follow the rule, denominator constant, and you can always cross check by multiplication rule, but we are directly coming to the formula. Denominator constant and differentiate the numerator. So here the rule is first you will have to give priority to the denominator and then differentiate the numerator. Minus, now keep the opposite, numerator constant and differentiate the denominator. And after doing so, the complete you have to divide by the square of the denominator without differentiating, just the square of the denominator. This is to be done. The most important example which can justify this is what we call as tan x. We have already seen the differentiation of tan x is sec square x. You can always cross check by this. Example, now several differentiations you can obtain from here. Example first, if I have y is equals to tan x, we know differentiation of tan x is sec square x, but how we can get by division rule? Let's see. Tan x I can write sine by cos. So see the numerator and denominator and see the rule over here. So what we can say from here, dy by dx, first I will keep the denominator constant cos x and I will differentiate the numerator. Numerator is sin x. See the numerator, sin x differentiation will become cos x. I am doing exactly what I have done here. Focus properly. Denominator constant, differentiation of numerator cos x. Now here minus numerator constant, numerator is sin x. Chalapati Kurra, no need of telling me what is the rule and all. You have seen whatever is written on the board. Focus on that and compare and see whether, I don't have that much time, that presently from here I will be looking what the big comment you have written, but compare with this. If you have written exactly same, that means it is correct. From my side I can assure you that I have written correctly. So cos x into cos x minus, now keep the numerator constant sin x, differentiate the denominator. Cos x differentiation is, we know, is minus sin x. Cos x differentiation is minus sin x divided by whatever is the denominator, just square it. So cos x ka square. Now if you see at the top, you have cos into cos, which is cos square. Now here you see minus and minus, which will become plus sin squared x. In denominator you have cos x ka square, which is nothing but cos square x. So here we can see cos square plus sin square we know is 1. So cos square plus sin square is 1. We have 1 by cos square x, and 1 by cosecant square x is nothing but secant square x or sec square x. Sorry, not cosecant, cos square x. Extremely sorry for that. 1 by cos square x can be written as sec square x. So you can see that the differentiation of tan x becomes secant square x. Is it clear to everyone? So by division rule, we can get any such formulas which can somehow be expressed as division. So if you have such doubts, sir, what if we have secant x, or what if we have cosecant x, what is their differentiation? Beta, you can do by this only. I am just telling the another one. For example, if we are given, you can see from here, sometimes they will say tan x, so we know secant square x, but what is y is equals to secant x. So if they give you y is equals to secant x, so we can write secant x as 1 by cos x. Now if I want to write dy by dx, I will use the same rule. Denominator constant, differentiation of numerator, 1 is a constant, 1's differentiation will be 0, minus numerator constant, differentiation of denominator, differentiation of cosecant, cos x is minus sin x, divided by whatever is the denominator, just square it. Now first term becomes 0 into anything 0, minus becomes plus, so we get sin x by cos square x. Sin x by cos x, there are two cos x, so sin x by cos x is tan x, and one more cos x will be left. So when you take this cos up, so you get 1 by cos is sec, so sec x tan x. So sec x tan x is the differentiation of sec x. So these type of terms where we can express them as division of something, like sec x is 1 by cos x, by division rule you can see that we get dy by dx as sec x tan x. Is it clear? One more quick example, then we will move ahead. Third example we are taking, suppose y is equals to ln x by x. Y is equals to ln x by x. So you can write dy by dx as first x constant, differentiation of log x 1 by x, minus log x constant, differentiation of x is 1, divided by denominator square x square. So this will cancel x, you will get 1 minus ln x by x square. Just see. So division rule, multiplication rule, addition rule, subtraction rule, constant alone, constant multiplied by a function, these all we can see that how we can differentiate it easily. Is it clear? But it is not ln x square. Ln x becomes 1 by x, so x 1 minus ln x by x square. This is the answer. Sir, how can we know? It cannot be further simplified. Beta, there is no need of knowing until and unless you get an objective question. First of all, you know that in NEET you have objective questions. Whatever question is asked, if you have differentiated, you have to bring the answer, final answer as one of the options given. Okay, so this is what common sense says, that if I have 4 options given in the question and I am differentiating and seeing that none of the options is available, that means either I have done it wrongly or I need to simplify it further. Is it clear? So in that way you will come to know whether it is to be simplified or not. The best part of NEET exam is that you have got 4 options. So once you solve it, after that if you see that all the options that are given, none of them are present in what you have found, that means you have to either check your differentiation properly or not. If you think or confident that yes, I have done it correctly, then simplify it further so that you can achieve the final form. @FF team, you are wrong. Please remove your comment and try and see what I have done over here, what you are writing. Ln x by x square or minus, the format which you are writing, it is not correctly shown over here. So that's what I am saying. Write in proper form. Okay. Now let's move. As I told that gradually whatever we are learning, we'll try to use it in physics. So till now what all rules we saw, based on that, let's see applications in physics. So when we say applications in physics, so you should know that if I denote x is position of a particle and t is time, then First of all, delta x means final position minus initial position in any time interval. This we denote by the letter S, which I have told is nothing but displacement. Now, when we write delta x by delta t, which is displacement by time interval, we had called it average velocity. Remember? But if you are writing dx by dt, differentiating x with respect to time, we will call it as v, which is instantaneous velocity at any time t equals to t. So when we had seen uniform motion and all, that time I told average rate of change of position is called as average velocity, and you should know the difference between position and displacement. The change in position means final minus initial, it is called as displacement, whereas the rate of change of position with respect to time, that is displacement by time interval, it is called average velocity in an interval. Average velocity in this interval, whatever interval you are taking, delta t. But if you are writing dx by dt, it will give you instantaneous velocity. Understood? And we had also seen whenever we take mod v, that is magnitude of instantaneous velocity, this is called as instantaneous speed. So instantaneous speed at any moment, at any instant, is nothing but the magnitude of this velocity. If it is, because speed can never be negative, so whatever, velocity can be positive, negative, everything, but speed can be positive or zero, but it cannot be negative. So we take the mod magnitude, that is called as instantaneous speed. Clear? So if you have x as a function of time, you can write velocity as dx by dt whenever they are asking. Yes, delta t is the interval, beta I have written over here. Delta t is the interval. Interval, you are finding average velocity. Average velocity in the interval. In different intervals, you will have this. Don't worry, I'll take everything by example. You be completely relaxed, I'll take everything by example so that these things go and sits over here and sticks there. So here velocity magnitude is the instantaneous speed. Now, if suppose velocity is also changing with time, velocity is a function of time. So when they are saying velocity means instantaneous, if they write average, then you will understand it is in interval. Otherwise, if just v is written, it is velocity. So velocity is a function of time. Then here again we have two types of rate. One is average, delta v by delta t, which is change in velocity by time interval, which is final minus initial. Final minus initial by time interval. This will be called as average acceleration. Average acceleration in that interval. In an interval. When we are taking interval of delta t, and delta v by delta t denotes average acceleration, and dv by dt, if you take rate of change of velocity at an instant differentiation, this will be called as instantaneous acceleration. At any given time instant t equals to t. Is it clear? Yes. So, very important application, if x is given as a function of time, dx by dt is instantaneous velocity. Velocity is given as function of time, then you have acceleration, which is dv by dt. Are this clear to everyone? Shall I proceed? Okay. Next we have, now I told acceleration is dv by dt, right? If I multiply mass both sides, can I write like this? Acceleration is dv by dt, so if I multiply mass both sides, m here denotes mass, we can write. Now what happens if mass is constant? Suppose mass is constant, then I had told you, if I take mass inside, will there be any problem? If mass is constant, so I know when I will differentiate something, I can take mass outside. Remember our second rule of differentiation, which I told, that if something is constant, keep that constant outside the differentiation. Can I write like this? Just tell me. If mass is constant, I can write m dv by dt also as d by dt of mv, because m is constant, so it comes outside, right? So what we can see, that m into a is equals to d by dt of mv. D by dt of mv, yes. So this ma is called as F, which is net external force, and mv is called as linear momentum, which we denote as p. So we get something which is called Newton's second law, F is equals to dp by dt, or in vector form, since both are vector quantities, so you can use arrow also to show. F vector or force is nothing but external force, obviously. So external force is equals to rate of change of linear momentum. It is called rate of change of linear momentum. Both are vector quantities, so I have just represented them with arrows. So we can write net external force acting on any body is rate of change of linear momentum, which is also called as, you very well know, Newton's second law of motion. So any body, if acted upon by a net external force, means several forces, one or more forces may be acting, the net vector sum, if we take all forces combined, that force will be equals to rate of change of linear momentum. Clear? So this is also one important application of physics, where we relate or correlate momentum and force. So if momentum is given, then we can find. So we have limited time in which we are discussing the things. Beta, it won't be possible for me to give recap right now, because we are into something interesting and important. Okay, and moreover, I don't like wearing caps, so I cannot give you a recap. Okay, cap, hat, anything, bandana or anything on the head I don't wear. So if I don't wear a cap, I don't give recap when I am into something important. So better focus here now. Later on you can see. Now next, there is something which is called as chain rule. There is something called chain rule. Gujjala Charanya, we are presently not into Newton's law discussion, because it will kill our time for utilization of something important going right now. I just gave a brief idea. When we will be seeing the chapter Newton's law of motion, there we will discuss in detail a lot more of what you have studied. You will come to know that you have studied a very meager or a small amount. Newton's law, first law, second law, third law are not actually what you have read. It is way beyond that. Lot of concepts are there, important concepts are there. You just have had a basic idea of that, but in that chapter dedicated for NLM, you will see that lot more things are to be known. Focus here. So we will be coming to the examples of whatever I am writing, but before that, one more important rule which is called as a chain rule. Because this is also used over here, focus, chain rule in differentiation. Now what does this rule say? Let's see. Chain rule in differentiation. So chain rule says that if suppose y is a function of u, y is a function of u is any variable, u is any variable, and u is a function of x, y is a function of u and u is a function of x. That means indirectly y is a function of x also, because y is depending on u and u is dependent on x. So indirectly we can say, indirectly y is a function of x and directly y is a function of u. Directly y is a function of u. So what is this Zamzan Zan? A sir, which he can't give a recap. Okay. I am not getting you. I think you need to work on your English. So and here chain rule in differentiation. Achha, you are worrying. See here, this is chain rule. Instead of making the icon like this, that what is going on. Okay. Focus here, you will understand what is chain rule. So when we have y is a function of something else, which indirectly is a function of x, then chain rule says what? See, if they ask you find dy by dx, you will say, Arey sir, how can we find dy by dx? Y to is a function of u. If y is a function of u, it should be differentiated with respect to x. Sorry, with respect to u. But you are saying dy by dx. So here the chain rule comes. What is chain rule? Y is a function of u and u is a function of x, and if they ask me dy by dx indirectly, so what I will do? I will change the base. So this chain rule is also called as base changing rule. Chain rule is also called as base changing rule, where what we do, dy by dx, since y is a function of u, then I should differentiate it with respect to u. I should differentiate it with respect to u. But you will say, Arey sir, how can you do so? How can you do so? We don't know base is dx, why will you put du? I will say definitely I can't put by myself. If I have put, means I have committed a mistake, I should rectify it. What should I do? If I have divided here, so I should multiply it so that it gets cancelled. Now you will say, yes sir, now it is okay. But where is dx? Put it back. See? So instead of a single term dy by dx, you have got a chain of two terms being linked together. See, chain means you have links. Now you have two links which are together with this multiplication sign. This is called as chain rule. So now you can see dy by dx is dy by du into du by dx, where y is a function of u, so it should differentiate with respect to u, into du. Now u is whose function? X. If u is x function, then du by dx you can do. There your chain stops. This is what we see. Now if you see, okay, I am the worst teacher in the world, accepted. Now anything else you can do, Zanzan. I think you try your level best, you can't do anything to me. What I am, I need not explain to people like you. Better focus on the class or simply leave the class. Don't show these all types of comments in before me. You will be simply removed. I don't care a hell about such students who are not into listening to the class and unnecessarily writing comments. So don't try to be too smart in front of me. Okay, I was born smart, and as I grew up, I became smarter and smarter. So don't act smart, focus here. Dy by du into du by dx. Now here, once we have this thing, so what we can say, best example, suppose they give you velocity is a function of x. In physics, we are talking of physics example. So velocity instead of function of time, they say that, acha, what if velocity is a function of x? So x here is position, or velocity is given as a function of displacement, whatever form they give you. This form they give, where s is displacement and v is velocity. So what we will do here, if they ask me what is acceleration, now I know acceleration, sir, you told me acceleration is dv by dt. I will say yes, I have told this thing, acceleration is dv by dt. So if acceleration is dv by dt, but you will say, sir, you just told that v is a function of x, so it should be differentiated with respect to x, not t. So I will say yes, I will differentiate v with respect to x by this chain rule. And since I have done this mistake of writing dv by dx, so can I multiply dx and dt and write like this? See, dx cancels, dv by dt, you are getting acceleration. So here dx by dt. What is dx by dt? Dx by dt is nothing but velocity. What is dx by dt? We know dx by dt is velocity. So you get acceleration as another very important example, which is v dv by dx. So another important formula which you are going to study in physics, if they give velocity not as a function of time, kindly remove this gaming students. Okay, it seems that you are a big fan of Balakrishna, so better you go and watch his movies instead of listening to my class. Remove. A is v dv by dx. So here, if velocity is given as a function of x, you write acceleration as v dv by dx. If velocity is given as a function of time, then you write acceleration is dv by dt. Understood? So focus here. We can get acceleration in two ways. Now why I have told all this thing, why this drama is going on? Why this drama is going on? Because we will now see the example in physics and we will justify the formulas which you already know, uniformly accelerated motion. We will see whether we are getting the same thing that you actually see in the expression. So three terms, velocity dx by dt, acceleration dv by dt if velocity is a function of time, and acceleration v dv by dx if velocity is a function of position or displacement, anything. If it is given similarly displacement, you can write acceleration is v dv by ds. If position, v dv by dx, if displacement, v dv by ds. Understood? Let's see finally example in physics. So those who are not listening but impatiently waiting for example, now here I come with example. Example, if I talk of uniformly accelerated motion, where we know acceleration is constant. Acceleration is constant. So let's see. Now displacement. What is displacement? Displacement is nothing but change in position, which you can write, suppose the final position is x and initial position is x naught. This is the position at t equals to 0. This is the position at any general time t equals to t. Today I am repeating it for once and last time. From next time onwards, while I am writing something, those who are sincerely listening, kindly listen. Otherwise, any other thing, simply you will be removed. What I am doing over here is explaining the concepts and taking example. Don't teach me when to take chain rule example and all. I am taking example of chain rule only. Focus over here. So, any other comments which are not pertaining to what I am teaching, simply remove them. So here x minus x naught, all these things like right full form, half form, short form, remove. X minus x naught, uniformly accelerated motion, x minus x naught. This displacement, I know the formula is ut plus half at square, ut plus half at square. Do we know this? Yes. Now if I want to find velocity, so what I can do, I can differentiate s. You will say, but sir, how can you differentiate s? Because s is change in position. So if you differentiate both sides with respect to time, you see what will happen. You will write like this, x minus x naught. For example, suppose you say that sir, I don't know that v is ds by dt. No problem. Just write ds by dt. ds by dt, if you write, you will write d by dt x minus x naught. Now you will write this side also. You will write d by dt of ut plus half at square. See properly what we are going to get. Now when you write ds by dt, let's see what we are getting first. Dx by dt. First you will get dx by dt. What is dx by dt? It is v. Dx by dt is v. What is x naught? X naught is your initial position, which is a constant. This value is a constant. This value is a constant. This acceleration is constant. This initial velocity is constant. These are constants. So when you will differentiate by subtraction rule, dx by dt becomes v. Now here please dx naught by dt constant 0. So next u dt by dt plus a is a constant, 2 is a constant, you will differentiate t square. Now see what you are getting from here. ds by dt, rate of change of displacement, is nothing but velocity. Now what is velocity from here? Beta, it is u. dt by dt is 1 plus, what is the differentiation of t square? We know t square differentiation is 2t. So you can see we get our final form, ds by dt is equals to v and it is equals to u plus at. This is the formula that you study for uniformly accelerated motion. V is equals to u plus at. Understood? Now again, you can see v is equals to u plus at. This becomes a function of time. This becomes a function of time. If v is equals to u plus at is a function of time, let's see what is acceleration. I know that a is acceleration, but I have to prove it. I have to prove that a is acceleration. How can we prove from here? Let's see. If they ask, tell me sir, what is acceleration? So I will say, beta, I don't know acceleration is dv by dt because v is a function of time. Let's prove that a is acceleration. See here. So I will write d by dt of v is how much? U plus at. Now I will use addition rule. Du by dt, u is a constant plus a is a constant, dt by dt. Now see, u is a constant, so differentiation will become 0 plus a into dt by dt is 1. Arey, remove this jhadu ka jhadu also. Who is that? He is willing that I get sick. You can will beta, whatever. There is no control on our emotions. You can even wish that I die. Okay, I will be very happy with that. But the thing is that your wish cannot be transformed into reality always. So focus here. Those who want to focus, those who want to write unnecessary things, you can go on. 0 plus a. So you see from here, acceleration is equals to a. Acceleration is equals to a. Yes, so this is acceleration. Understood? And last example which I will take, because I told about chain rule also, so I can also write in uniformly accelerated motion. We know v square equals to u square plus 2ax. Do we know this thing? v square is equals to u square plus 2ax. If you go by this formula, you can see that if I write v square differentiation with respect to x, v square differentiation with respect to x. Now what you can say by chain rule, you will say that sir, v square to we know differentiation, but that will be with respect to v. So I can put by my own wish v. I can put own wish v. If I put v, then I have to multiply also and divide also. Just see here. If I put by my own wish dv, then I have to divide also and multiply also. Now see what you are going to get here. V square differentiation with respect to v is nothing but 2v. So 2v dv by dx. You are getting how much? 2v dv by dx. So from here you can see v square differentiation, you are getting 2v dv by dx. But if you see on the LHS, this is LHS. If I differentiate on right hand side, then you will say, sir, I have to differentiate right hand side also with respect to x. Please do. U square is a constant, u square differentiation will become 0. Plus 2a is a constant, and x with respect to x will become 1. So you can write 2v dv by dx is equals to 2ax. So 2 cancels. And what is dv? V dv by dx. I told just in the previous page, v dv by dx is acceleration. So you can see acceleration is, I'm sorry, this was not x. Acceleration becomes a. So by chain rule, we can justify that the acceleration is a. So LHS, RHS, we can substitute and prove by chain rule that yes, here in uniformly accelerated motion, a denotes the acceleration. So it was a bit of hurry. In the end, I did it rightly. In next class, we will be again seeing this thing, and as I have been telling, you may find lot of teachers who are simply, they will entertain you because they feel that NEET students are to be pampered, but I am seriously not of that sort. If you write anything vulgar against me, I will definitely retaliate, and if you are present before me, you can never dare to do that so. And second thing, if anyone thinks that sir, you fall sick, you can wish for me to die as well. I won't care a thing about that. Whatever you wish me to do, I can live as per my own terms. I am not going to simply tolerate such students who don't have anything to do with studies. If you don't want to study, waste money of your parents, you are free to do so, right? But inside the class, whether it is online or offline, I am not going to tolerate any such type of indiscipline. Clear? So if you want to study, better focus on the class, and you know that at the end, always you can watch your videos and you can pause them wherever you want. You can continue writing that thing, whatever you want to do. So I am not at all bothered about your whether you like me, don't like me. If you don't like me, very good for you. But if you are in the class, then better that please focus. I am here to teach you, but no, I won't tolerate any indiscipline. So that will be all. So for all the other students, wish you all a very good day. Let's see tomorrow's class, and whatever I left in the end or did in the end in a hurry, my mistake. In the next class again we will be discussing chain rule in detail. Thank you.